So now we're going to model some virtual circuits with a platform called Tinkercad. This is what their general website looks like, so if you just go to tinkercad.com, this page will show up. If you don't already have an account, just press this Join Now button and it'll walk you through creating an account. But I'll just log in here so we can start. Before we begin actually designing, I just wanted to talk a little bit about the Tinkercad platform and some of my favorite features. The first is this gallery tab. This is a collection of people's most extravagant designs. So Tinkercad does circuits, but it also does 3D modeling, which you can see here. So if you click on any of these images, they will have descriptions of the part that was created. They'll have the source files as well as descriptions of how they went about making whatever it is and why they made it. You can also click the circuits tab to see their circuit-based or Arduino-based projects. This is a really great source of inspiration, especially if you're just beginning to understand what is possible with the types of things that you're learning. They also have a blog page. This is where individual users will post blogs about different projects that they're working on and what they're doing. So that can be a great source as well. What's most useful is this Learn tab. So this is a collection of tutorials and it's broken up within 3 parts. So there are these starters, which are the basics of how to use the software. Then there are lessons, which is a step above that, which are small items. Then there's also projects, which are more complicated designs. So these will walk you through step by step in the exact same software, so you can just split your page between their tutorial and your design and see how it all works. So that's for their 3D modeling. They also have the same setup for their circuits, and they also have some code blocks that you can learn some basic coding as well. So this is a really great place to learn and try new things. I have learned everything that I know about Tinkercad through their tutorials in this Learn tab, so I highly recommend it. But for today, we're going to walk through just creating a basic design. So here we're going to go to circuits and then create new circuit. And this will bring us to the general page. So how this works is the right hand side has all of the components that you can potentially use. So right now we're on the basics tab, which is what we'll use all today. But if you select all, you can see all the potential things that you can add to a circuit, which is probably pretty overwhelming, but don't worry. You don't have to learn how to use everything all at once. They're just there. So we're just going to go back to the basic for now. Another cool feature is that if you select the sidebar, it will add descriptions to each of the components. So if you forget what it does or how it works, that can be really helpful to jog your memory. This general middle space is where you're going to be doing your designing. And so all you have to do is just click and drag a component out. Then this pop-up will show up, which will allow you to set the parameters for whatever it is that you're dragging in. So in the case of an LED, the only thing that you can really change is the color. We're just going to keep it as red. You can also name components if you'd like. When you're selected a component, you can rotate it around like so with this rotate button. There's also a delete button, an undo. There's like a redo button. And so those can be helpful as well. So the first thing that we're going to do is just build a LED circuit. So the first thing that we're going to need for that is a battery. So the easiest way is just to search the components for what you're needing. So in this case, this is a 9-volt battery that we're bringing in. And so one of the important things about these components is that they will have the ports labeled when you hover over them. So this helps tell you which place to wire what. So this is the negative end and this is the positive end of this battery, which will help us. So we already have an LED, we have a battery. The only other thing we need is a resistor, so we can go and drag a resistor. Now the resistor, you can change the resistance. So just because we have one LED, we're just going to set it to about 350. That's just generally the resistance value that works best with LEDs to ensure that they don't break. And so what we can do is the way that the LED is broken up is there's the anode and the cathode. And so we always want to make sure that we're putting the anode with towards the positive end of the battery. Otherwise the light bulb won't work, won't turn on. But if you end up switching this up accidentally, no worries. You can just try it one way and then flip it if it doesn't work. So you wire things together either directly by putting components on top of each other or by dragging and dropping wires. So I'm just going to do this here and select and then connect those two. Then we want the resistor to connect as well. So I'm just rotating that just to make it a little bit easier. And then I'm completing the circuit by dragging and dropping around. And one thing that you'll notice is that as I'm dragging and dropping, if you select and press down when you're dragging a wire, it will create a corner for you like this. And that can help just make your circuits look a little bit nicer. Yeah, so then none of the circuit is going to light up or get any power until you press the start simulation. So you can see that our LED lights up. So yay, that's good. Another thing that's important about this is this resistance value. So we know that with Ohm's law that resistance and current have an inverse relationship. So if you increase the resistance, you're going to decrease the current and vice versa. So we can see that if we increase the resistance to be really big, we're going to decrease the current that gets put all the way through the circuit. So that is also going to make this LED dimmer. So we can see that it lights up a lot less. And in the same way, if we decide to make our resistance really, really small, like this, and we start the simulation, we're going to get an error. And so this error is telling me that the current is too high. So the LED can only work with less than 20 milliamps of current, and the way we have it currently set up has 551 milliamps. So if you ever get this error, just know that that means that you have to increase your resistance. So most of the time for a single LED, that's about 350. So now take a minute and try to drag and drop the components just like this on your own account and see how it works for you. So the next thing that we're going to do is we're going to make a circuit that turns on an LED based off of a motion sensor. So the motion sensor that we're going to be using is a PIR sensor. So you can see that it's a passive infrared motion sensor used to sense motion in front of it. So before we actually wire into any circuit, I'm just going to show you how this component works. So if we start the simulation, you can see, we're going to zoom out here so you can see, this represents the motion. So you can see the two light up red circles means that the sensor is sensing motion. And if you do it outside of its scope of vision, then you're not going to activate it, but only movement within the scope of vision is going to activate it. So that's how it generally works. There are three important ports to this sensor. So there's a power that's in the middle, and there's a ground. So these are what we're going to use to connect to our main battery. And then there's a signal. And so the signal gets activated or turned on whenever something is detected. So this means that this sensor acts kind of a lot like a switch. If there's nothing there, then there's no current, and if something moves in front of it, then current gets put into this signal port. So we're first going to start by picking our battery. So our battery here is a little bit different because we know that this sensor works at about 5 volts, and so we have this 9-volt battery here, but that's too big, and this 1.5 volt battery is too small. And so what we're going to do is we're going to press the count, and we're going to put 3 of these together. So when you put these batteries together like this, it means that all of their voltages add up. So we have 1.5 plus 1.5 plus 1.5, that is 4.5, and that's close enough. So if you ever get a component that's not acting like it should, you can just Google what voltage it works on. And this is only true for the PIR sensor because underneath this actually is a circuit board and actually has some computing. So this is kind of like a miniature chip of sorts, and so that's why it has a particular voltage. But most of the components that you'll be dragging and dropping in work on any voltage, but this one is just specifically 5. So that's why that is. So the first thing that we're going to do is just going to connect our power to our ground. So again, we can hover over these ports to see which ones connect to which. So our power, we want to connect that to our positive end, and then our ground, we want to connect that to our negative end. That's just general convention. If ever you see negative or ground, just always put those together, because that means that there's going to be no voltage in that part. So the next thing that we're going to do is we have to think about what we want activated out of the signal. And for us, that is a LED. So what we're going to do is we're just going to get an LED here. So you can just search for items like this. And so we've dragged an LED. And we're also, whenever you add an LED, you always want to put a resistor with it. Otherwise, you're going to get way too much current going through the LED, and it'll break with that error that we saw before about the current being too high. And so what we can do here is we're just going to drag this. I'm going to rotate this just so that it's a little bit not in the way anymore, because we can also drag this out to give us a little bit more space. So in general, because the current is going to be coming as positive out here, we're going to connect the long end of our LED, or the anode, this way. But again, you can always just put in the LED, and if it's not lighting up correctly, you can just spin it to make sure that it works. So the last thing that we have to do is we have to make sure that our circuit gets closed. And so this means that this is kind of like our positive end, because that's where the current is going to be coming from. And then we're just going to ground this along with the other one. So we can connect multiple things to the same port. It doesn't matter, just drag a wire. So we can also I'm just going to drag this just so we can see it a little bit better. Like so. Okay, so now if we press start simulation, you'll notice that it's not lighting up at all, and this is because the sensor has not been activated. So I'm going to zoom out a little bit, and so we can see when it gets activated, the light comes on, and if we are not activating it, the light turns off. So this is one really cool application of using a kind of fancy type sensor to make a light turn on. Now take a few minutes and see if you can follow along and recreate this PIR circuit that we walked through and see how it works. So the last thing that we're going to do is create a circuit with a component called a potentiometer. And so we can see from the description here that it's a type of resistor whose resistance changes at the turn of a knob. So instead of changing the resistance like we did here by selecting and then inputting the values in the drop-down window, we're instead going to be changing the resistor as the circuit is on with the knob that we will see here. And so in this way, we'll be able to make the LED brighter or dimmer in real time as the circuit is running. So in order to make this work, we're going to need a battery, just like we do for any circuit. And so one also cool thing about Tinkercad is if you need more space, you can just select at any of the gray space and then slide over and make anything you want move over. So we are going to need the potentiometer, which will act like our resistor. We're going to have a battery, and then we're going to need an LED as well to see things light up. So the wiper in this scenario is the middle port, and this is what's going to be the changing part of the potentiometer. So this is the branch that will have the varying resistance in it. And so that's what we're going to connect to our LED, because that's the part that we want to see the changes in. So again, we're going to be connecting the long or anode end of the LED into this because we know that the positive current is going to be flowing out of our component. But if you get this mixed up, then you can just put it in however you think, and then if you accidentally mess it up, just use the rotate button and flip it and try it again, and then that will work just as fine as well. But in general, you want to be putting the anode end in outside of most of the components because they're going to be producing positive voltages. So we're going to want to ground this so that we're going to have this positive end coming out, and then the negative end will just go back to the negative side of our battery. And then the other side of this that we're going to be looking at is these outside terminals, which are the positive and grounds of the potentiometer. So what we're going to do is just connect these to our positive and ground ends of our battery just by dragging wires. And the last thing is when we select the potentiometer, there's going to be this drop-down menu that comes and it asks you for resistance. And this resistance is going to be the maximum resistance of the potentiometer. So it's a dial, so it's going to be changing, but what do you want the max to be? So in our case, we're just going to set this to 1,000 ohms, and that'll give us a pretty good idea of how it's going to change the brightness. So now that we have this all wired up, we can press start simulation, and you can see that right now we're getting a current error because our resistance value is really low. So if you select on the potentiometer and then move the dial, you can see that when we have a really low resistance, we get way too much current going through. And then as we increase the resistance, we're getting a first that error goes away, and then the LED gets dimmer and dimmer. And then if we make the resistor really, really high, then you can see that it's not really lighting up at all. So this is another cool way to show how Ohm's law works in a basic circuit. And this is also a way that you can make an LED slowly fade out, or a lot of different applications. But yeah, so this is generally how. So now I'm going to give you a couple minutes to try to make this potentiometer circuit on your own. Try and drag the components and see how it works for yourself. So that finishes our Tinkercad tutorial. Hopefully that was helpful in getting you started with simulating some basic circuits virtually and learning how Ohm's law applies to a couple different scenarios.